In section 2.4, we will be working with solving higher degree polynomial equations. Our objectives will be that you will be able to solve quadratic-like equations and solve general polynomial equations by factoring. Quadratic-like equations are equations that is quadratic in form. If it can be written in the form an squared plus bn plus c equals 0, where a, b, and c are constants and n is an algebraic expression. Such equations can be solved by first solving for n and then solving for the variable in the expression n. This method is called substitution. To put this simply, what we need to have is we need three terms. Second, the ratio of the exponents on the variables has to be 2 to 1. Okay, for this to work. And then we will use what we call the U substitution to solve it. In my first example, I have x to the fourth power plus 15x squared minus 16 equals 0. I will use the U substitution principle to solve this. Notice that the exponents are in ratio 2 to 1. The bigger exponent is twice the smaller exponent. That makes it quadratic-like. Also note that the highest power on x is 4, so that means this is a fourth degree polynomial. That will provide us with 4 solutions when we are finished. To solve this, I will start by letting u equal x squared. Always let u equal the variable with the smaller exponent. Then u squared would equal x squared squared, or x to the fourth power. By substitution, we can say we have u squared plus 15u minus 16 equals 0. I replace the x squared in the original problem with u, and I replace the x to the fourth power with what it's equal to, u squared. I have now a quadratic equation. This will factor. U plus 16 and u minus 1 equals 0. Solve for u. So either u plus 16 equals 0 or u equals negative 16, or u minus 1 equals 0 or u equals 1. Well, we've solved for u, but the original problem was in terms of x, so we need to back substitute and replace the u's with x squareds. And to solve for x, we will take the square root of both sides. Side opposite the variable gets plus or minus, and that yields x equaling plus or minus 4i, or x equaling plus or minus 1. Now I have my 4 solutions: positive 4i, negative 4i, positive 1, and negative 1. I would also like to show an alternative way of working this problem. This will be straightforward factoring, and you may use this process as well. This will only work when our exponents are in ratio 2 to 1. We will factor this like we would a regular quadratic, except for in the first positions, instead of putting just x, I will put x squared. The two numbers that multiply to get negative 16 but combine to get 15, again, are positive 16 and negative 1. If we FOIL, x squared times x squared is x to the fourth. I'll have a negative 1x squared and a positive 16x squared that will combine to get 15x squared. And positive 16 times negative 1, of course, is negative 16. Now we set each of those factors equal to 0 and solve them for x. On the first side, we subtract the 16 over. On the other one, we'll add the 1 over and then square root both sides. Side opposite gets a plus or minus. And we're right back where we were before. Plus or minus 4i and plus or minus 1. We will have other types of polynomial equations that we need to be solved, and in this section we will solve them by factoring. Some hints. If the polynomial has 4 terms, we will factor by grouping. If the polynomial has 3 terms and is not quadratic, then look for a greatest common factor. And then the third one, the polynomial has 3 terms and is quadratic, then use the quadratic formula. This third statement is what we just did in the previous example, and I will have examples of the first two here in a moment. Factor by grouping is a step in our AC method of factoring. You must have 0 on one side. Write the non-zero side in descending order. Group the first 2 terms together and then the second 2 terms together. Factor the greatest common factor from each of the 2 groups. When done correctly, the 2 parentheses should be the same. And then factor out the common parenthesis. And the second parenthesis will contain the greatest common factors. We'll have an example. In this example, x to the third plus 3x squared minus 9x minus 27 equals 0. We have 0 on one side, 4 terms on the left, so I will factor by grouping. I group the first 2 terms together and the second 2 terms together, including the sign on the third term. Now in the first group, I can take out an x squared, and that will leave in parentheses x plus 3. In the second group, I can take out the negative 9, which will also leave x plus 3. The 2 parentheses are the same, so I will write down the common parenthesis, and then the greatest common factors will make up the second, x squared minus 9. And we have this polynomial factored. Now I can break this down one more time because this factor is quadratic and it's actually a difference of 2 squares. So I will factor one more time. I have the x plus 3 that was already there. And then I'll have another x plus 3 times x minus 3. And when we solve these 3 factors, I'll have x equals negative 3, x equals -3, or x equals +3. This is a degree 3 problem, so I should have 3 answers, and I do. It happens that 2 of them are the same number, and that can happen. Okay, and just as a side note, I have 3 linear factors. Degree 3 polynomial, 3 linear factors, 3 solutions. My last example on this section, 7x to the third plus 48x squared equals 7x. I need to have 0 on one side, so I will subtract the 7x over to the left-hand side. This equation has 3 terms on the left, so we cannot factor by grouping. The exponents are not in ratio of 2 to 1, so we can't do the quadratic like factoring. But if you notice, all 3 of those terms contain an x, so I will factor out the common x. So we have 2 factors. The factor inside the parenthesis is a quadratic. Now you could set that equal to 0 and use the quadratic formula if you wish, or you can factor further. I will use the AC method to factor this problem out. In this problem, A is equal to 7, B is equal to 48, and C is -7. I'm going to take A times C, which will be -49, 7 times -7, and I need to find 2 numbers that multiply to get -49, but at the same time combine to get +48, and that would be 48 and -1. So I'm going to rewrite my quadratic factor here in 4 terms. I'll have 7x squared plus 48x, that should be 49x, minus 1x minus 7. So I've just took the 2 numbers I found and replaced them here in the middle, and I combine these, I get 48x. Now, since I have 4 terms, I will factor by grouping. In the first group, I can take out a 7x, which will leave me x plus 7. In the second group, I'll take out the -1, which will leave x plus 7. The 2 parentheses are the same, so I'll write that common parenthesis down, and then in the second parenthesis, I'll put the 7x minus 1. And now I'm going to bring down that x from up above, and I have my 3 linear factors. So I can set each of those equal to 0 and solve for x. So my solutions are 0, -7, and +1/7.